Assalamualaikum and good day. We are from Group 12, which consists of 3 members, me, myself, Muhammad Azhar bin Muhammad Syafuddin, and Muhammad Amiruddin bin Muhammad Rudwan, and Muhammad Nabil bin Syaiful Tuah. We'll be talking about the topic differentiation and related rates. What is differentiation? So, differentiation is a process to find a function that output the rate of change of one variable with respect to another variable. There are 6 subtopics under differentiation. The first one is the definition of differentiation. The second one is the derivative of function. The third one is the techniques of differentiation. The fourth one is the chain rule. The fifth is higher derivative. And the last one is the linear approximations and differentials. So the other applications of differentiation are to find the critical points, to calculate the minimum and maximum value of particular function, to find the absolute extrema, to determine the slope of graph, for problem optimization, and lastly for business applications.
Looking to question number 9, a hot air balloon is attached to a spool of rope that is 125 feet away from the balloon when it is on the ground. The hot air balloon rises straight up in such a way that the length of rope increases at a rate of 15 feet per second. How fast is the hot air balloon rising 20 seconds after it lifts off? So, first thing first, jot down all the information stated in the question. The first one is the distance between the spool of rope and the balloon is 125 feet. 125 feet. And the rate of the length of the rope increases at a rate of 15 feet per second, or the ds over dt is 15 feet per second. So how do we know whether the ds over dt is negative or positive? So looking into these words, increases, we can know that this figure is positive 15 feet per second, because increases meaning that the value of this figure will be more or will be increasing in time. So the question asks us to find the dh over dt of the hot air balloon 20 seconds after it has lifted off. So using chain rule, the equation will be dh over dt when t equal to 20 seconds equal to dh over ds multiplied by ds over dt. So how do we get this equation? Okay, first, we already had the ds over dt, which is 15 feet per second. So in order to cancel out the ds and replace it with dh, we put dh over ds here, so that the ds will be gone, will be cancelled out, and the end result will be dh over dt.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nabil bin Syaiful Tuah, and I will be talking about the problem statement. The question asks us, how fast is the hot air balloon rising 20 seconds after it lifts off? So the problem is, based on the information given, which is the distance between a hot air balloon that is attached to a spool of rope that is 125 feet away from the balloon when it is on the ground. And the other information is the hot air balloon rises straight up in such a way that the length of rope increases at a rate of 15 feet per second. So we have to use both of these informations to find how fast is the hot air balloon rising 20 seconds after it lifts off. Now I will be talking about the objective of this question. What do we want to solve, and what do we want to find? So based on the questions, it directly asks us how fast is the hot air balloon rising 20 seconds after it lifts off. So that is our objective.
Hi, Assalamualaikum. So it's my turn. So from the question 9, we can extract all the information given by the question. We can conclude that this is h, this is s, and this is x, where x equals to 125 feet. From the question also, given that ds over dt, where rate of change of s to respect of time equals to 15 feet per second. From the question, They want us to find the rate change of h to the respect of time, dh over dt, when t equals to 20, right here. So the chain rule would be dh over ds times by ds over dt. Okay. So as we can see right here, this is a 90-degree 90-degree triangle. So we can use the theorem Pythagoras, where s square equals to h square plus x square. Substitute the value of x into the equation, and then find the h in terms of s, where we got the s square minus 15,625 to the power of 1 over 2. Differentiate on the right hand side, we got 1 over 2 times by 2s times by s square minus 15,625 to the power of negative 1 over 2. So this is our dh over ds. So we already have the dh over ds and ds over dt. So we just substitute those value into the chain rule. But wait, here stated is t equals to 20, but in the equation we don't have any t. So we look at here, where 15 feet in 1 second. So in 20 seconds times by 15, we got 300 feet. So you can see here 300 feet. So s equals to 300, substitute value of s into the equation, and then we got the rate change of h to respect of time when t equals to 20 is 16.501 feet per second. Let's go to the conclusion. In related rates, idea is to compute a rate of change of one quantity to another rate of change of another quantity. After that, we need to use chain rule to relate those quantities to each other and differentiate both sides respect of time. That's all from Mirul and us. Thank you. Assalamualaikum.
Two damn phones, Babylon's can't crack the code. Two damn phones, Babylon's can't crack the